So my name is Alphonse Prakash, and in today's video we'll be solving this question on Leetcode, which has been asked in Facebook interview. So the question is square of sorted array. So this question looks very simple in the beginning, but it actually uses the two-pointer approach. So so let me explain the question. So in this question we have an array, and this array is already sorted, and it also contains negative and positive integers. So the output should be in such a way that suppose we square all the elements, then the output should be the sorted value of the square of all the elements. So as you can see, this minus 4. So the square of minus 4 is 16. So it's not in this, no, it's not in the zeroth index. It comes to this index, and like this. So it's actually so in this question actually we have to first square all the elements and then we have to sort it. So if we follow the naive approach, that is the brute force approach. So what will happen is, like suppose this is the array, and suppose we square all the elements. So this becomes 16, this becomes 1, this becomes 0, this becomes 9, and this becomes 100. So we can sort this in we can sort this like 1, 9, 16, and 100. So this is our output. So the time complexity for this approach will be O of n log n, and the space complexity will be constant. But this approach is not a very optimized approach because it's still taking O of n log n, and this question can be solved in a better time complexity than this. So this question can be solved in a better time complexity. So what is my approach is that we'll make two vectors. The first vector will be containing all the negative values. So my approach is we will be creating two vectors, and both vectors will be containing the square of the negative values. So in like suppose vector negative, the values will be 16 and 1, and the second vector that is positive, the values will be 0, 3, and 10. Sorry, the values will be 0, 9, and 100. So what I will do is first I will reverse the negative because it's in descending order and we want it in ascending order. So so always it will be coming in descending order. So we have to reverse it. So once we reverse it, so my negative becomes 1 and 16. So once this has happened, so suppose earlier this was in my nums vector. So what I will do is I will be comparing the first index of both the negative and the positive, and the lowest value will be added to my nums zeroth index. So in this case it will be 0, and then I will be shifting to 9. Actually I will be using two pointers. One pointer will be pointing to 0 and the second pointer will be pointing to 1. And as I've already added 0, so this pointer will be moving to 9, and I will be comparing 1 and 9. And in 1 and 9, 1 is smaller, so I will be adding 1. Then my my pointer will be moving till 16 to 16. So I'll be comparing 9 and 16, and 9 is small, so I'll be adding 9. And then my pointer will be moving to 100, and I will be comparing 16 and 100. So 16 is smaller, so I'll be adding 16, and then I will be adding 100. So this is the approach. So the space complexity for this will be O of n, because we are making two different vectors, and the time complexity will be n linear. So this is the most optimized solution for this. Actually, we can solve it in one more approach, but that approach will be also following the same time complexity. So in that approach, what we'll be doing is we'll be creating another array, say like answer array, and all the values in the answer array will be initialized to 0, and the length of answer array will be the same as that of the nums array. So just like this. So here we go. So first we will compare it. We'll be comparing the square of this and the square of this. So the theory is that the maximum value will be either on the first index or on the last index, because suppose it was minus 14, so the maximum value would have been the square of minus 14. So this is the theory. So first we are comparing the zeroth index and the last index, and we'll be checking which has the highest square value. So 100 has the highest square value, so we'll be substituting this in the last index like this, and we'll be moving the pointer to 3. Then we will be comparing 3 and minus 4. So the square of minus 4 will be 16 and the square of 3 will be 9. So this is more. So we'll be putting the value of 16 over here. Square of minus 4, 16. Then we'll be moving the pointer to 1. Then we'll be checking whether the square of 1 is greater than 3 or not. The square of 3 or not. So it's not. So we'll be putting the square of 3. So that's 9, and we'll be moving the pointer to here, and then we'll be comparing this and this. So the square of minus 1 is 1 and square of 0 is 0. So we'll be putting 1, which is the square of minus 1, and then we'll be putting 0. So this is the answer. So this algorithm will be also working in O of n time complexity, and the space will be also O of 1 because we are making another vector as named as array. So talking about the summation. So this is the summation. So this summation, we first created two vectors, positive and negative, and then we substituted all the negative values in the negative vector and substituted all the positive values in the positive vector, and then we reversed the negative vector like this, and then we did this algorithm. Whichever value is the lowest, we'll be just substituting it to the nums. So suppose if the value of j, suppose one second. So let's say that the length of the negative vector was 4 and my j is 0. So j is actually representing the negative vector and k is actually representing the positive vector. So let's say that the value of j was 0 and the value of the size of the negative vector was 4. So once j reaches to 4, so it will be accessing the it will be accessing those addresses which are out of the bound. So it will be giving us some errors. So we have to keep that also in mind. So if j is equals to the size of the negative vector, then we will be just substituting it with the size of the positive vector, and we'll be increasing it, keep on increasing it. Okay, and let's suppose that it happens in the opposite way, like the size of k matches to the positive size vector. So we will be just keep on adding the negative vector and adding it and increasing the index of the negative vector. But suppose if both these conditions are false, so we'll be comparing that whether negative is small or positive is small, and whichever is small, whichever is greater, we'll be just substituting it. Else we will be just sorry. And if both these conditions are false, we will be checking whether neg of, and if both these conditions are false, we'll be checking if neg is small or pos is small, means at j and kth index. So whichever is the smallest, we'll be just substituting it. And if pos is smallest, we will be substituting the pos, and then we will be returning the nums. So this is the approach, and this is the by far the most optimized approach as it is working quite well. So this is the video. Please subscribe to get all the videos. Thank you.